All right, let's do some problems here. So, problem number one, it says a single photon has a wavelength of 420 nanometers. Calculate its frequency and its energy in joules. So, a couple things up here at the top. We've got the equations and all the information that we're going to need in order to do this. So, this is our first equation, that the speed of light is equal to wavelength times the frequency. And then we've got the energy equation, where energy is equal to Planck's constant times the frequency. And then I've got your Planck's constant, speed of light, and Avogadro's number up here. All of these things are on the AP test, except this one, knowing that 1 meter is 10 to the 9th nanometers, or if you'd prefer, you could say that 1 nanometer is equal to 10 to the negative 9th meters. Both are true, whichever is most convenient for you if you want to do it that way. All right, so anyway, what they have done here is they have given us wavelength. So because they have given us wavelength, they have given us this. And of course, we know that the speed of light, c, is this. So we have two of the three things from our equation. It's just a simple plug and chug, making sure we get all of the units right. So what we're going to do is we're going to start with the speed of light. So that's 2.998 times 10 to the 8th, and that's in meters per second. And that is going to be equal to 420 nanometers. But remember, if you're talking about nanometers, you can't do nanometers and meters in the same equation. It won't work. So you're going to have to change one to the other. I prefer to change nanometers to meters and just call that 420 times 10 to the negative 9th meters, because remember, a nanometer is 10 to the negative 9th meters. So just replace the nanometers with times 10 to the negative 9th meters and you're on your way. So 420 times 10 to the negative 9th meters, and then that's going to be multiplied by the frequency. And then this is a simple matter of plugging things into your calculator and getting your answer. So your answer here is that the frequency should be around 7.14 times 10 to the 14th inverse seconds. All right. Now 1b is it wants to know what the energy is in joules. Well, if it wants the energy now, then clearly it wants to know what this is. So in order to know the energy, you've got to know Planck's constant and the frequency. Well, nice thing is Planck's constant they gave us here. So h is always the same, never changes, hence the term constant. And we just went and solved for the frequency right here. So we can use our answer from A to do B, and we don't even have to do anything else. So we're in good shape. So then the energy, E, is going to be equal to Planck's constant, 6.626 times 10 to the negative 34th. And that's in joule seconds. And that's going to be multiplied by 7.14 times 10 to the 14th inverse seconds. Again, that is simply our answer from before, because again, energy is equal to h times the frequency. So multiply those two together and you have your answer. So if you do the math on that, you should get, if I have done my math correctly, no guarantee I have, of about 4.73 times 10 to the negative 19th, and that's joules, and that's for one photon there, right?